Welcome to the Age of Dinosaurs. Have you ever tried to imagine a world without any people? No cities, no cars, no schools, and no houses? It's a wild thought, isn't it? Well, a very, very long time ago, that's exactly what our planet was like. It was a world ruled by incredible creatures, giants that shook the ground with every step. These amazing animals were the dinosaurs, and they lived on Earth millions of years before the first humans ever appeared. So if you've ever seen a cartoon or a movie with a caveman riding a dinosaur, that's just for fun. In reality, no person has ever seen a living, breathing dinosaur. It's a mind-boggling idea, but it's true. These magnificent reptiles roamed the Earth during a time we call the Mesozoic era. That's a big name, but it just means middle life. This era was so long that it split into three parts: the Triassic, the Jurassic, and the Cretaceous periods. The dinosaurs first appeared in the Triassic period about 230 million years ago. That number is so huge it's hard to even picture. Imagine counting to 1 million and then doing that 230 times. That's how long ago these animals began their journey. They were the kings and queens of the planet for an unbelievably long time, living and thriving for over 150 million years. Think about what the world must have looked like back then. The continents were in different places, slowly drifting apart to form the world we know today. The air was warmer, and the land was covered in strange-looking plants, like giant ferns and towering ancient trees. There were no grassy fields to play in, as grass hadn't evolved yet. Instead, vast forests and steamy swamps covered much of the Earth. This was the perfect home for dinosaurs, providing plenty of food for the plant eaters, and lots of places for the meat eaters to hunt. It was a wild and untamed world, a true animal planet. So if no one was around to see them, how do we know so much about these incredible creatures? The answer lies hidden right beneath our feet, buried in the rocks of the Earth. The dinosaurs left behind clues like a secret diary written in stone. These clues are called fossils, and they are the reason we can piece together the amazing story of the dinosaurs. From tiny footprints to massive skeletons, these fossils are our only window into this lost world. They tell us what dinosaurs looked like, what they ate, and how they lived. It's a puzzle that has taken hundreds of years to solve, and there are still so many secrets waiting to be discovered. For thousands of years, people probably stumbled upon strange giant bones sticking out of the ground. They might have thought they were the bones of mythical giants or dragons from ancient legends. They didn't know these were the remains of real animals that lived long ago. It wasn't until the 1800s that scientists started to put the pieces together. In England, a brilliant scientist named Sir Richard Owen was studying some of these massive fossil bones. He looked at the bones of three different creatures that had been discovered: Megalosaurus, Iguanodon, and Hylaeosaurus. He realized they were unlike any living animal he had ever seen. Sir Richard Owen noticed that these ancient reptile bones had some things in common. They were different from the lizards and crocodiles of his time. He believed they belonged to a whole new group of animals that had gone extinct. In 1842, he needed a name for this incredible group. He combined two Greek words, Deinos, which means terrible or fearfully great, and Sauros, which means lizard. And so, the name dinosaur was born. It means terrible lizard, which is a perfect name for these powerful and awe-inspiring creatures. Sir Richard Owen helped the world understand that these weren't just random bones, but evidence of a lost age of reptiles. This new name, dinosaur, sparked a huge wave of excitement all over the world. People became fascinated with these terrible lizards. Soon, a dinosaur rush began, especially in North America. Scientists and fossil hunters raced to the American West, where huge bone beds were being discovered. They were finding skeletons of dinosaurs that were bigger and more complete than anything seen before. It was a time of great competition and adventure, as everyone wanted to be the one to discover the next new species. These discoveries filled museums with towering skeletons that captured the imagination of everyone who saw them. The work that Sir Richard Owen started continues to this day. We are still finding new types of dinosaurs all the time, in every corner of the globe, from the frozen lands of Antarctica to the vast deserts of Africa. Each new discovery adds another piece to the puzzle of what the world was like when dinosaurs ruled. The name he created, Dinosaur, has become famous worldwide, representing some of the most amazing animals that have ever lived. It all started with one clever scientist who looked at old bones and saw not a monster, but a magnificent new chapter in the history of life on Earth. So, what exactly is a fossil? It's not just an old bone. A fossil is the preserved remains or traces of a living thing from a long, long time ago. Most things that die simply rot away and disappear completely. For a fossil to form, some very special things need to happen. Imagine a dinosaur, maybe a big plant eater, dies near a river. Its body sinks into the soft mud at the bottom. This is the first important step. The mud and water protect the body from scavengers that might eat it, and from the air that would cause it to decay quickly. The soft parts like skin and muscles rot away, but the hard parts like bones and teeth are left behind. Over thousands and millions of years, more and more layers of sand, silt and mud pile on top of the skeleton. This is called sediment. The weight of all these layers becomes incredibly heavy, pressing down on the bones below. Slowly, water seeps through these layers of sediment. This water is full of dissolved minerals like tiny bits of rock. As the water trickles through the bones, these minerals start to fill in all the tiny empty spaces. Very, very slowly, the original bone material is replaced by these hard rock minerals. It's like making a perfect stone copy of the original bone. This process is called petrification, and it turns the bone into a rock-hard fossil. Fossils aren't always bones though. Sometimes paleontologists find fossilized footprints. Imagine a dinosaur walking through soft mud. It leaves behind a perfect footprint. If that mud is buried quickly and hardens into rock, that footprint can be preserved for millions of years. These are called trace fossils, and they are super exciting because they show us how dinosaurs moved. We can see if they walked on 2 legs or 4, if they traveled in herds, or if they were running. We can even find fossilized dinosaur eggs, sometimes with tiny baby dinosaur skeletons still inside. Even dinosaur poop, called coprolites, can become fossilized, telling us what they ate. These amazing stone treasures can be found all over the world, wherever the right kind of rock, called sedimentary rock, is found. They are often discovered in places where wind and water have worn away the layers of rock on top, exposing the fossils underneath. Deserts, canyons, and badlands are fantastic places for fossil hunting because there isn't much soil or plant life to cover up the rocks. Finding a fossil is like finding a message from the past, a piece of buried treasure that tells a small part of the incredible story of life on our planet. It's a direct link to the world of the dinosaurs. Who are the amazing people who find and study these incredible fossils? They are called paleontologists, and they are like detectives who solve mysteries from the ancient past. Instead of looking for fingerprints and clues at a crime scene, they search for fossil clues buried deep within the Earth's rock layers. Their job is to piece together the story of life on our planet, one fossil at a time. It takes a lot of patience, knowledge, and a spirit of adventure to be a paleontologist. They have to know about rocks, which is called geology, and about animals, which is called biology, to understand the clues they find. The adventure for a paleontologist often begins with a fossil hunt, or what they call a dig. They travel to remote places like the rocky badlands of Montana or the deserts of Mongolia, where dinosaur fossils are known to be found. They walk for miles and miles, with their eyes glued to the ground, searching for tiny fragments of fossil bone weathering out of the rock. This is called prospecting. When they find a promising spot, the real work begins. It's not like digging for treasure with a big shovel, it's very slow and careful work. A paleontologist's job is part scientist, part explorer, and part puzzle solver. These dinosaur detectives don't just solve the puzzle of what a single dinosaur looked like. They also try to figure out how it lived. By studying the shape of its teeth, they can tell what it ate. By looking at its leg bones, they can guess how fast it could run. When they find many dinosaur fossils together, they might learn that those dinosaurs lived in herds, like elephants do today. Every single fossil, no matter how small, adds a new clue. They are constantly asking questions. How did this animal move? What sound did it make? Did it care for its young? It's a giant puzzle with millions of pieces scattered across the globe. Once the fossils are carefully removed from the ground, the work is still not over. The bones are taken back to a laboratory or a museum. There, skilled technicians called preparators spend hundreds of hours cleaning the rock away from the fossil. They use tiny drills, like the ones a dentist uses, and delicate picks to reveal the bone underneath. Then, the paleontologist can study the fossil up close, compare it to other discoveries, and maybe even realize they have found a brand new species of dinosaur. Their work helps build the towering skeletons we see in museums, and brings the world of the dinosaurs back to life for all of us to see. Section 5. A prehistoric who's who, the stars of the dinosaur world. When you think of dinosaurs, a few famous faces probably pop into your head. The most famous of all is the mighty Tyrannosaurus rex, or T-Rex for short. Its name means Tyrant Lizard King, and it definitely lived up to its name. T-Rex was one of the largest meat-eating dinosaurs that ever lived, stretching up to 40 feet long, which is longer than a school bus. It had a massive head filled with railroad spike-sized teeth that could crunch through bone. Despite its ferocious reputation, T-Rex had two tiny arms that have puzzled scientists for years. What did it use them for? We're still not entirely sure, but we know it was the top predator of its time during the late Cretaceous period. Another superstar of the dinosaur world is the Triceratops. Its name means three-horned face, and it's easy to see why. This plant eater had three impressive horns on its face, one on its nose and two long ones above its eyes. It also had a huge, bony frill that protected its neck. Triceratops was built like a tank and was about the size of an elephant. Those horns weren't just for show, they were likely used to defend against predators like T-Rex. Imagine a battle between a T-Rex and a Triceratops. It would have been an epic clash of two of the most famous dinosaurs of all time. Now let's talk about a dinosaur that became a movie star, the Velociraptor. In movies, they are often shown as big, scaly, and super intelligent pack hunters. The real Velociraptor was actually much smaller, about the size of a turkey. But don't let its size fool you. Its name means Swift Caesar, and it was a fearsome predator. Paleontologists know that Velociraptor was covered in feathers, much like a modern bird. It also had a long, sharp, sickle-shaped claw on each foot that it could use as a terrifying weapon to slash at its prey. So while it wasn't as big as in the movies, it was still a very cool and dangerous little dinosaur. Of course, we can't forget the long-necked giants, the sauropods. Dinosaurs like Brachiosaurus and Diplodocus were some of the largest animals to ever walk on land. Brachiosaurus, whose name means arm lizard, had front legs that were longer than its back legs, giving it a giraffe-like posture. It could reach high into the treetops to munch on leaves that other dinosaurs couldn't get to. These gentle giants were so enormous that the ground must have trembled when they walked by. From the king of the tyrants to the horned defenders and the feathered hunters, the dinosaur world was filled with an incredible variety of amazing animals. Section 6. What's for dinner? Carnivores versus herbivores. Just like animals today, dinosaurs had different diets. You can learn a lot about what a dinosaur ate by looking at its teeth and its body. Scientists divide dinosaurs into two main groups based on their food choices: meat eaters and plant eaters. The meat eaters are called carnivores. The word carnivore comes from Latin words meaning flesh and to devour. Carnivorous dinosaurs were the hunters of the prehistoric world. They had features that helped them catch and eat other animals. Most had sharp, pointed, serrated teeth like steak knives that were perfect for slicing through meat. Famous carnivores like Tyrannosaurus rex and Allosaurus were apex predators, meaning they were at the top of the food chain. They had strong legs for chasing down their prey and powerful jaws to deliver a crushing bite. Other carnivores, like the Velociraptor, were smaller and probably hunted in packs to take down larger animals. They relied on speed, sharp claws, and teamwork. Not all carnivores ate other dinosaurs, though. Some, like Baryonyx with its long crocodile-like snout and cone-shaped teeth, were excellent fish eaters. By studying their skeletons, we can see that these hunters were built for a life of action and pursuit. On the other side of the menu were the plant eaters, which are called herbivores. The word herbivore comes from Latin words meaning plant and to eat. These dinosaurs came in all shapes and sizes, from the giant, long-necked sauropods to the armored stegosaurus and the horned triceratops. Instead of sharp, pointy teeth, herbivores had teeth that were designed for snipping, stripping, and grinding tough plant material. Some had flat teeth for crushing leaves and ferns, while others had rows of teeth that worked like scissors to chop up branches. Eating plants might sound easy, but it takes a lot of work to digest tough leaves and stems. Because they were often on the menu for carnivores, many herbivores developed amazing ways to protect themselves. Triceratops had its horns and frill. Stegosaurus had big bony plates on its back and a dangerous spiked tail, called a thagomizer, that it could swing at attackers. Other herbivores, like the duck-billed hadrosaurs, probably relied on safety in numbers, living in large herds. They also had excellent hearing and eyesight to detect danger early. The prehistoric world was a constant balance between the hunters and the hunted, the carnivores and the herbivores, each evolving incredible features to survive. Section 7. Digging up the past, a paleontologist's toolkit. When a paleontologist finds a fossil, they can't just pick it up and put it in their backpack. The fossil is often extremely fragile and still stuck in hard rock. Getting it out of the ground is a very delicate operation that requires a special set of tools and a lot of patience. The first tools they use are often larger, like shovels and pickaxes, but only to remove the top layers of loose dirt and rock that are far away from the fossil. As they get closer to the bone, they switch to much smaller tools. They use rock hammers, chisels, and awls to carefully chip away the rock surrounding the fossil. The most common tool you'll see a paleontologist with is a brush. They use brushes of all sizes, from large paintbrushes to tiny toothbrushes, to gently sweep away dust and dirt without damaging the delicate fossil surface. It's slow, careful work, and it can take days or even weeks to expose a single bone. As they work, they often apply a special glue called a consolidant. This liquid soaks into the fossil and hardens, making it stronger and preventing it from crumbling apart. This is especially important for fossils that have a lot of cracks. Once a bone is mostly uncovered, the team has to figure out how to get it back to the lab safely. They can't just lift it out because it would break under its own weight. Instead, they create a protective cast around it, just like a doctor puts a cast on a broken arm. They first cover the fossil and the rock it's in with a separator, like wet paper towels or aluminum foil. Then, they dip strips of burlap or plaster bandages into wet plaster and wrap them around the fossil, building up a hard, protective shell called a field jacket. This keeps the fossil safe for its long journey. After the plaster jacket is hard, the team carefully cuts the rock underneath the fossil and flips the whole block over. They make a plaster jacket on the other side, completely encasing the fossil in a strong, protective cocoon. They label the jacket with a number and notes about where it was found. Sometimes these jackets can be huge, weighing thousands of pounds and needing a crane to lift them onto a truck. It's a huge amount of work, but it's all worth it to make sure these priceless treasures from the past make it safely to the lab where their secrets can finally be revealed. Section 8. The Great Mystery. Where did the dinosaurs go? For 150 million years, dinosaurs were the undisputed rulers of our planet. They were incredibly successful, adapting to environments all over the globe. And then, about 66 million years ago, they vanished. It wasn't just the dinosaurs. About 3/4 of all plant and animal species on Earth disappeared in a geological blink of an eye. This event is called the Cretaceous-Paleogene Extinction Event, and it's one of the greatest mysteries in the history of science. For many years, paleontologists have debated what could have caused such a massive and sudden extinction. What powerful force could wipe out the mighty dinosaurs? The most widely accepted theory today is the asteroid impact theory. Scientists Luis and Walter Alvarez proposed that a massive asteroid, about 6 miles wide, slammed into the Earth. They found a thin layer of a rare metal called iridium in rocks all over the world that dated to exactly the time the dinosaurs disappeared. Iridium is rare on Earth's surface but common in asteroids. Scientists believe this giant space rock crashed into the ocean near what is now the Yucatan Peninsula in Mexico, leaving behind a huge crater called Chicxulub. The impact would have been more powerful than all the world's nuclear bombs combined. The immediate blast would have been devastating, but the long-term effects were even worse. The impact would have thrown trillions of tons of dust, rock, and soot into the atmosphere, blocking out the sun for months or even years. This would have created a global winter, causing temperatures to plummet. Without sunlight, plants would have died. Without plants, the herbivores would have starved. And without herbivores to eat, the carnivores would have starved too. The entire food web would have collapsed. It was a chain reaction that led to the end of the Age of Dinosaurs. While the asteroid impact is the leading idea, some scientists think other factors may have played a part too. Around the same time, there was massive volcanic activity in a region of India called the Deccan Traps. These volcanoes spewed lava and gas for thousands of years, which could have also changed the climate and poisoned the atmosphere. It's possible that the dinosaurs were already struggling from the effects of these volcanoes, and the asteroid impact was the final knockout blow. Whatever the exact cause, the world changed forever. But their story doesn't completely end there. One small group of feathered dinosaurs survived and evolved into the birds we see all around us today. So, in a way, the dinosaurs never truly left. Their legacy flies on, and who knows what secrets are still buried, waiting for the next generation of explorers, maybe even you, to discover.